Hello everyone, Wayne Parham, Lone Star Audiofest. I had considered bringing on someone to interview for this next session, but I've been on my mind all week long about seminars, so I'd like to talk to you about those. Honestly, that's to my way of thinking been one of the greatest draws of both the Great Plains Audiofest when we started, and then when we moved it to Dallas, the Lone Star Audiofest, is we just had such cool seminars. And now that I've partnered with Emeco, I think it will be a little easier to bring those together. Back when we started, I was kind of running around doing the show pretty much all by myself. I had some help here and there, but in the early days, I actually would even have to stop manning my own room because I have a little loudspeaker company, Pi Speakers. I'd have to stop manning my room to go kind of handle the seminar room, and we would record those, although we only recorded audio in the early days. I mean, back then in the early 2000s, you didn't have video on the internet. It wouldn't support it. You had little kind of toys like See You, See Me, and you know, a camera on the internet watching a toaster or something. But, you know, I think YouTube was started in maybe 2005, so it was really new. So we only recorded audio back then. And now is a perfect opportunity that we can record our seminars as video and put them on this channel. Some of the people that we've had, of course, I always did a seminar on crossovers. We had like Keith Larson, who some of you may remember. Parts Express sold this thing called the speaker tester. That was his Smith & Larson audio. And then he also made a very sophisticated, full-featured acoustic measurement system. So it didn't just test the woofers for small parameters, you know, the electromechanical stuff, but it would test, you know, you used a calibrated microphone, and it did all kinds of stuff. So anyway, he gave a seminar one year. We had like Brian Smith of Audio Note Kits describing, you know, Audio Note amplifiers and various technical aspects of those. Now that I think about it, I shouldn't name drop because I'll forget a whole bunch of others. There were so many really good seminars, and I intend to continue that trend now. We also have, of course, people that are talking mostly about their individual companies and their product offerings. Those are also very interesting seminars. And I think, again, now I think that with Emeco kind of helping me with this, you know, I can get some of the technical people. She can get some of the people that are kind of high-end audio. Like I said in the last edition of this video channel, YouTube channel, she kind of brings the stereophile crowd, and I think I connect real well with the Audio Express crowd. So I think we can have seminars from both of those types of companies. But I want to give you an example, too. I mentioned a minute ago the seminar that I gave many years, and still will. I called it Crossover Electronics 101. The materials are online. You can go to audioroundtable.com or pispeakers.com and find that, you know, the handout. And what that was I would make several examples of a crossover: first order, second order, third order, fourth order, and put specific filter functions in those crossovers, like CD compensation for a constant directivity horn, or now a low diffraction constant directivity horn, which we now call waveguides a lot of times. I call them waveguide horns. But anyway, that filter function, we'll put that in the crossover, and then something like a Zobel. And so what I'd do is I would show that circuit, and then I would play some sound, play some music through a loudspeaker that was being driven by that circuit. And so that really gave you a feel for how that type of crossover or filter function actually sounded. And what I found people found most interesting was things like the peaking that you get as an interaction between, say, the capacitance in the crossover and the inductance of the driver, which of course makes a resonant circuit. And damped somewhat by other aspects of that circuit, but it really will form a peak at crossover. And so you'd think just a single capacitor crossover is the simple purest type, but in some cases you can get a little peak out of it. And similarly, what really was surprising to many is if you take like a second order crossover, right? Coil and a cap, that's it. And you drive a woofer with that. Or it actually will happen on a third or fourth order too. If you don't have a Zobel, if you don't have that Zobel network, you'll see a huge peak near the crossover frequency. So, we show the circuit, then we show a spice model of that circuit showing its transfer function where you can actually see the curve, what it looks like, and then you hear it. We'd switch it on, and we'd switch the Zobel on, and you could select between the two, and you really heard that peak, and then you heard it go away. So that was cool. But crossovers, electronics, that's kind of a two-dimensional thing. And so in that seminar, that's kind of where it ends. We don't get into in my seminar, the Crossover Electronics 101, we just touch on some of the three-dimensional aspects, which would be the interaction between say the woofer and tweeter. If you got a two-way speaker, when you move vertically, straight forward to that speaker, you're the same distance between the woofer and the tweeter. But when you move up, you're closer to the tweeter and further from the woofer. A crossover can't really help you there because that's a three-dimensional aspect, and the crossover is going to provide a specific phase angle, a specific kind of time delay to each, the woofer and the tweeter. And so all that comes into play as to where those two drivers sum properly. You get too far up or too far down, they have destructive interference, and you get what are called vertical nulls. And that's another seminar I can give. In fact, I'm going to show you that in a minute, actually. There's a video I made about 15 years ago, and I tied it to a post on my loudspeaker forum where I show how I'm designing my crossover. And I use a spice model, and a spice model is a tool for electronics engineers that lets them model a circuit and then actually evaluate it. But I have another cool thing. I mentioned Keith Larson of Smith & Larson Audio and his acoustic measurement system. It lets you build a crossover with a spice model and measure with it. And that's how I develop speakers. And I'm showing that on my forum where I can literally type in the values to the spice model. I can change my Zobel capacitor or whatever else. I can change the capacitor in the high pass circuit for the tweeter. I can play with that stuff. And what I'm doing is I get the filter function real close, but then I dial in some slight subtle phase shifts by changing the values of certain components so that I can get my vertical nulls so that they're way up and way above the speaker and way below and uniformly spaced, not way up here, not way down here, but that way you've got a good pattern, say 20 or 30 degrees above to 20 or 30 degrees below. Everything in between there's just right. See, that's another seminar that I can do, and I'll show you a video of what I mean by that. Others I'd like to see, and we've done in the past, seminars on how the multisub protocol works to smooth room modes. And then, of course, my flanking sub mechanism. We can show how that works. We can show measurements. We can show different, people can show different types of amplifier topologies, single-ended, push-pull, ultralinear, parafeed. There's just a whole lot of those kinds of seminars that I intend to bring to the Lone Star Audiofest. And the next show, we'll put some of those together and other shows afterwards. So, I hope that you'll enjoy this next little clip where I'm going to show you how I measure vertical nulls. And then we'll do it again live with several people at the next Lone Star Audiofest. Thanks.
Hi, my name is Wayne Parham, and I'm here to talk to you today about how to find the vertical nulls on your loudspeaker. This is a 3-pi model loudspeaker. It has a DE250 compression driver on an H290 horn, and this one has a TD12S woofer, which is a new woofer for this model. In the past, it's had an eminence woofer, but I'm trying out this one to see if it'd be a good upgrade option, and it appears that it will be. One of the things I do when I design my loudspeakers, I use a 90-degree horn with uniform directivity, and I cross over where the woofer's directivity is collapsed to be approximately equal to that of the tweeter. That way I've got uniform directivity in the horizontal plane. Basically what that means is that the speaker sounds the same pointing straight at you as it does at 20 degrees, 30, 40 degrees off axis. So pretty much throughout the room it's going to sound the same. Another thing that I try to do is to make sure that the speaker's directivity in the vertical is uniform as well. And that one's a little more complicated because since the speakers are mounted vertically on a baffle, depending on where you are, up and down, you can be closer to the woofer or closer to the tweeter. If you get far enough from one to the other, then what happens is in the crossover band, which is around 1,000 to 2,000 hertz, there are certain positions that you're exactly a half a wavelength closer to either the woofer or the tweeter, depending on if you moved up or down. When that happens, there's a big notch, and that's what we call the vertical nulls. What I try to do in my speakers is to set the vertical spacing of the drivers and set my crossover so that on axis, as well as to a fairly tall vertical pattern, your response curve is clean, and only out at fairly wide angles do you hit those nulls. The way you find that basically is you set your microphone up, you move it above and below the speaker to find out where they are. Now, as you can see, my environment is not the best for making measurements. For making a production measurement, I take this outdoors and I measure it anechoically. But just to find these nulls, being indoors is not a problem. There's a lot of things that reflect sound, but I'm really only looking for the position of those nulls. It's at a fairly high frequency between 1,000 and 2,000 hertz, in the crossover range. So I don't really care so much about all these reflections. I'm just looking right now for the position of the nulls. Again, this is a development situation. We'll take it outdoors and measure it in a little better fashion when we're doing production. But for right now, let's find out where those vertical nulls are. First, we'll move the microphone towards the bottom of the speaker to find out where the lower one is. Now, as you can see, we've moved into a null. If you define the center of the loudspeaker as the forward axis, it's kind of an arbitrary thing to pick, but you would see that your microphone is now about 25 degrees below that forward axis. Being just 1 meter back, that's the distance from the front of the speaker to the microphone. Being just 1 meter back, your microphone isn't even quite to the bottom edge of the loudspeaker, but any reasonable listening distance, 2 meters, 3 meters, whatever, as you move that far back, then at that angle, you'd be way below the bottom of the speaker, so the speaker could be placed on stands and you wouldn't be in the bottom lobe, and that's what's important to me. The truth is, the forward lobe is actually pretty symmetrical with this crossover, and so it would be about the center between the woofer and the tweeter. But again, I don't really care so much where we define that center. What I do care about is that the forward lobe be tall enough that the listeners can't be in a null. Let's find where the position of the top one is. You can see we have to go pretty far to find the the upper null, you're about 40 degrees from the center of the loudspeaker. Now again, that's because acoustically, the center of the loudspeaker is pretty much an arbitrary thing. It's just a point of, it's kind of what we're calling the center. The acoustic center of the speaker is actually closer to here. If we were to do that, if we were to use that as our forward axis, then we would see that the nulls were 30, maybe 35 degrees above and below, which is pretty wide. I'm pleased with that. The nulls would actually start closer to 25 degrees. They'd hit a max at about 30, and then they'd fall off again at 35. But by the time you've gotten that far out, the tweeter has begun to fall off. It gains vertical control about 3,000 hertz, and so you'd see your notches as you saw fall off between 1 and 2,000 and come back up again because the tweeter isn't maintaining any directivity control. But at very wide angles, it'd fall off again because 3,000 and up, the tweeter does gain control. So those tall angles, you just aren't putting out any sound at high frequencies. Now the way to do all this is really a function of where you place the tweeter and the woofer, and setting your crossover so that your two sound sources, your woofer and your tweeter, are in phase when you're in front. There is a center. Again, the center of the forward lobe is it's between the woofer and tweeter, but pretty much anywhere in this range, you're in phase, and that's what I'm keying on. And the trick is, again, how you position the drivers and in the crossover. That's the hard part, is setting the crossover. I'm not going to try to go into everything that you do to set that up. We do talk about that in my loudspeaker forum, the Pi Speakers forum, and it's on audioroundtable.com. So love to see you there.
I hope you enjoyed that video about vertical nulls. That was really just an example of the kinds of content that we like to see at the seminars at Lone Star Audiofest. It's what you can expect to see, is that kind of stuff. And so, I hope to see you at the next edition of the YouTube channel for Lone Star Audiofest, and I hope to see you at the next Lone Star Audiofest event. Thanks. Bye-bye.